Okay, so in the first workshop, we basically were going through and really just truly getting your toes wet. Hopefully we'll get your whole foot wet today, as they say. You know, and we were looking at, I'm trying to remember, let's see if I pull up my objectives here, just getting you familiar with the interface and getting a feel for what it looks like to run and type in commands in R, and then getting used to doing the same thing in RStudio. So that was really kind of what we did last time, and just briefly introduce you to packages. So with R, you know, there's a lot that comes in the base package, but obviously, depending on what kind of analyses you're doing or more fancy graphics and things like that, there are packages that you add. So these are like add-ons. Same thing, both SAS and SPSS all have lots of add-ons. So if you, like I said, if you've never looked at the license for SPSS, our SPSS that we have here includes about, I don't know, 15 or 20 add-ons actually. So when you buy SPSS, you don't get all of that right out of the gate. And then, so for today, and I don't have a copy up here, but for today, I'm going to get you guys a little bit more familiar with working within the RStudio interface and getting more familiar with the environment. And when I talk about the environment, not just the environment of the software, but also the environment of, you know, the data handling piece, getting data objects in and out and so forth. And then we'll do a little bit of summary statistics at the end. And there are a few things here that I'll probably just put up here just for right now, take it at face value, and I'll try to explain a little bit more about data structures like as we go, as well as in some of the future workshops. So again, for those of you that just came in, the network is down, so I can't pull up some of my cool stuff that I had online. I think it's still down. Anyway, so we'll see. Maybe we're lucky it'll pop back up in the next half hour or so. Okay. So when you start, I think it's always a good idea to do a couple of things. If you're starting a new project, go ahead and create a folder out on your computer or out on your cloud account or wherever you want to work. And make sure that A, you have that directory ready to go, and then B, that you've told R where you're going to be working. So this is that whole get working directory, set working directory that we did last time. So just to show you on mine, and by the way, I have saved this R code and I've put it out on a Dropbox. So everything that's here that I'm going to script and type is actually out there. And then it's also in that little online book that I did with all the annotation. It shows you what was typed, the output, etc. So you have both in theory, eventually when we get online. So when I first open my RStudio, a couple things you'll notice. Notice I've got a bunch of stuff in my global environment. So I'm gonna, in addition to making sure I'm working in the correct directory, I'm also gonna clean up that so that I start with sort of a clean slate. Now that's when you first start a project. When you actually, once you kind of get, you know, you've already created some objects, you've got like this version of that data file and this version of another data file, and then this is a subset that you were doing some analyses on. You know, you can save that whole thing, and then once you've got that environment saved, every time you open this back up, it'll reload that environment. So you don't have to like start from scratch every time. It's just the first time you start a project, it's a good idea. That way there you don't just have a bunch of extra things hanging around here. Matter of fact, this one doesn't have it, but there's another project that I was working on playing around with some of these CDC data sets, and one of the data sets that I downloaded was 1.5 gig. So it's like I don't want to carry around 1.5 gig in my memory if I don't have to, so because it slows things down. Okay, so can you guys see that okay? Is that font size good? All right, I'm finding font 14 is working for me just standing up here. All right. So if we do this first command, which is the get working directory, the way mine's set up, it defaults and it thinks I'm in my sort of users document folder. I'm not entirely sure kind of what a Mac would do. There are ways, and I was going to show you guys a couple more things here. In the RStudio Tools window, there's a bunch of different things in here, as well as in, like where we install packages, and I showed you briefly in the first workshop that, but we'll do some more today on that. Which, Depending on the network, we may or may not be able to do that. I already have them installed on my system, so it'll work for me, but y'all may not be able, because to install a package, you actually go out on the internet and download it. So, which, by the way, if you start using this more routinely, once you've got your packages installed, if you're offline, say you're on an airplane flying somewhere and you're trying to get work done, as long as they're installed on your system, you can always load them back. So I'm just giving you a heads up. If you're ever getting ready to go on a trip and you're a little unsure about your network, try to make sure you've got stuff installed before you go. Anyway. Let's see. All right, global options. And I sort of glossed over some of this last time. This is a little bit like, how many of you guys have ever looked in the SPSS edit options? Maybe. Anyway, if you've never looked at it, I encourage you to take a look at it. SAS has some stuff like this too, where there's like some initialization stuff that you can set up for like where you're working, what your home directory is, that kind of thing. And RStudio has that as well. Most of this stuff I wouldn't mess with, just leave the defaults. But there are a few things in here that are helpful to look at. Let's see. Trying to think. See if there's anything here I want to point out. For right now, I probably wouldn't change any of that. The main thing you might want to play around with is your appearance. So this is where I came in and changed my font to 14. It makes it a little bit bigger. So depending on which computer you're working on, I know for my little Surface Pro, which I just love, when I'm connected to an external monitor, font size is not usually a problem. But the screen real estate on the Surface itself is about 10 inches. So if my font's too small, I'm sitting there going, so sadly I'm getting old people eyes. I need to make my font bigger sometimes when at home. So that's one way to do that. And then there's 1,000 themes you can choose from. I'm using this Dreamweaver theme, but then there's all these other different color schemes that you can apply. Pane layout, again, you're welcome to play around with this. I usually just keep the defaults, but some people like other things to be shown than are shown by default. This is more important when you're doing a lot more programming and debugging kinds of stuff, which you guys probably won't be getting into that too much yet. Packages. This is useful to see. So by default, it sets up the CRAN mirror. So CRAN is that comprehensive R something network. I can't remember the exact acronym, but there are others. So if for some reason, I'm trying to think, if you've ever gone out and pulled files or something and it's like, okay, well, you could pull it from a server in Tennessee or you can pull it from a server in California or Georgia. Anyway, sometimes depending on what part of the country you're in, it works better if you're connecting to something that's closer by. There's some similar things here. So there's CRAN mirrors all over the world, and those are places that serve the different packages and add-ons and data sets and things like that. So this is one place where that can be changed. We're going to talk. Yeah. Oh, okay, so if we click change.
No, just that whole box to begin with.
Oh, okay, sorry. It's under Tools, Global Options.
At the got it. Thank you.
Sure. It's probably still trying to find CRAN mirror, so I just killed it. Anyway, so yes, question. Okay. So you can do it either way, and hold that thought, and I'll show you here in just a sec. So in addition to the packages thing, which will make more sense a little bit later on as we're adding more stuff, in Workshop 3 I'll talk a little bit more about this. Sweave basically is this idea that you're weaving code and documentation together. So that's kind of what I'm going to focus on in Workshop 3, where we're actually writing some R code and also writing the report at the same time with all of the data handling, the statistics, and the plots, and so forth. And this is how that gets configured. There's a spell check. I'm not in the series of workshops I'm doing now. I'm not going to get into this, but I will mention SVN stands for subversion control, and Git is another. It's basically a version control system, which this is really important if you're writing code and sharing it with others. But I actually encourage you to kind of take a look at some of these tools simply because it doesn't have to be computer code. If you're sharing a data set, if you're working on multiple manuscripts or doing report editing with a team, there are some really nice cloud-based systems. Well, like, how many of you in here have ever done anything or worked on a team and done Google Documents? Same kind of thing. So, and I don't know what the version control is behind Google, but these are two others, and I actually use Git. So I just mentioned that. And then there's some other stuff here on publishing. Maybe by the time we get toward the end, I'll talk more about that. All right, so let me come back and answer Irene's question. Okay, so I think it's useful to capture the codes to make sure that you're setting your working directory where you think you're setting your working directory. Believe me, I mess that up in SPSS a lot. But the other place you can do that is in, not there, hold on. Is it in here? Yeah, hold on. Trying to remember. Okay, it is in session. So this is the other place that some options can be set, and you have some other things that you can do. So in your session that you're running, and this, as we're up and running, this is a session, you can set your working directory here. So like suppose I was here and I just say choose directory. So I can actually come out on, just like any other file explorer, I think what I'm doing for the purposes of this. So if I work my way to the folder that I'm going to be working in and say select folder, you'll notice down here it's actually under the hood running that command, but you can get to it through the menus. So oh, this is just telling me that it's not connected to the internet. It finally figured out it can't get to the crayon mirrors, so just ignore that. But I think it's useful to capture that code. That way there you remember, or if you're sharing it with somebody else and you're like, no, really, we were out here on this research shared drive and this is the location, and anyway. And this doesn't have to be your local hard drive. I mean, this can be anywhere. Matter of fact, if I get a chance, maybe towards the end of the semester, I'm going to show you guys how to, there's actually ways you can interact with stuff out on the internet. Maybe not so much for set working directory, but I know people that do some of this stuff and work in and out of Dropbox. I know there's ways to do it in and out of Google Documents. I just haven't tested all that yet. Yeah. Okay. I think so. I'll admit I haven't used this a lot. So this is kind of like a miniature file explorer. And so yes, I think what this is that I'm actually now in this folder. It lists the files. Right. So yeah, good question. All right, so these are just some of the different things for setting things up. And I'm going to talk a little bit about workspace here in a minute. But this is where, and as a matter of fact, I'll show you this in a minute. This is where, like, suppose all of those objects that are listed over here in my global environment, if I say save workspace, it's going to go to the directory that I'm in, and I could say, current data objects or something. And it's, when I save it, and I'll show you where this goes. Notice down here it says save image, and I'm going to actually show you guys this function in a minute. But it wrote this whole thing on its current data objects, and I know it scrolled off the screen there. I'm going to scroll this back over so you can see it. It automatically gives it a .rdata extension, and .rdata is R's native data format. And I use data in a very broad term because this data is not one data set. It's everything that was over there, which is multiple data sets, it's multiple objects, it's different variables. It could be output from a linear regression. It could be a whole bunch of stuff. So it saves that entire thing. and it's in our data. The nice thing about that is I can load that back in, and I could actually show you that here real quick. So suppose this command here, which is remove, and it says remove everything in my list. So if I run that, clears my global environment, which again is a nice place to be when you first start a project. But if you didn't want that, you're like, oh, I really want to bring that back. Then we would use the load workspace, and now I can go get that thing I just created, which is this current data objects.rdata, and say open, and it runs this load command. So I've got a little bit later on, I'm going to show you how to do that. And you don't always have to save and load the entire workspace. You can save and load individual objects as well, which is one way to get data in and out of R. The good thing about that is it's fast and R understands it. The bad news is no other software is going to understand it. So like I can't send you an R data file. You're not going to be able to open that in SAS or SPSS. So the second part of what we're going to do today is showing how to work with those other kinds of files. So, but the R native data format is really handy. All right, so I'm going to go back and clear my workspace. And even though obviously you can see it, formally you could run the little list command and it's going to come back and say, yep, it's empty. Not really sure why it says character, but anyway. So this just confirms, yes, my workspace is now empty and clean and ready to go. A couple of little housekeeping things, and I don't have this in all of the notes I put online, but you can always, if for some reason R gets hung, most of what we're doing here, this shouldn't happen, but every now and then if I'm running something that's got a big long script and it hangs or I create garbage somehow, you know, there's a way like in, I've never had real good luck. There actually is a interrupt or a terminate command in SPSS, although you'll click it and you're still waiting 5 minutes for it to stop running. I've had better luck in SAS. There's actually like a kill command in SAS. So like if you start a thing, I have students every semester that decide to do a chi-squared test and they run a cross tabulation table between, let's say, age and country of origin. And it's like, okay, there's 50 ages and 100 countries of origin. So, you know, SAS is trying to figure out how to create a 50 by 100 crosstab table, and it's like running and running and running. And they're like, I don't know what went wrong. I'm like, well, you ran a crosstab on a continuous variable. So, just giving you a heads up. But that happens, and then you have to be able to go and find a way to kill the session. So, one way to do that in R is you can tell it to restart R, and it'll actually kind of like clean everything up and sort of bring you back to like a vanilla state, which is helpful sometimes. So, and this is the other place you can clear your workspace. So it says, are you sure? Yes. And it'll basically do that same command. That's actually up here under session. There's also a clear workspace command, which is basically what we just did. So, but you can get to it through the menu system as well. All right, so enough about bookkeeping. So we're going to create some objects. The first one's just going to create a number because it's just simple math. So 3 times 8 plus 6, and we'll create it and stick that answer in an object called x. The next line, we're going to create a sequence of numbers from 1 to 12. So we sort of did some of this last time, and we're going to put that sequence of numbers in an object called y. We could then create a new object, y2, and just square, take the squares of everything there. So I'll do a couple of these. So now we've got x with a value of 30. Here's y. It's integers from 1 to 12. If I square those, it automatically changes it to numeric. There's still 12 of them, but now it's 1, 4, 9, 16. All right, so this one's a command that I briefly showed. Mom, actually, I might not have shown this one. But suppose I wanted to combine y, y2, month abbreviation, and month name. So the month abbreviation and month name, those are like built-in constants in R. Obviously, there's 12 of them. So each of these things are vectors of length 12. So I can kind of shove them all together. So this is almost like me saying I'm going to let y be my first column, y2 be my second column, then I'm going to have the month abbreviations and month names. And I'm going to bind them together column-wise. So there's a cbind command. There's also an rbind command. So like if I had data on subject 1, subject 2, subject 3, I could bind them together by row. So just know this is, and this wouldn't be the best way to do it, but this is one way to quickly build a little data set using sort of pieces of information. So if I use this cbind command, I'm actually going to build my first data frame, which is why I called it df. And so when I do that, you'll notice everything in it's a character variable because the month abbreviation and month name are characters. So if I open this up, you can see it put everything together. The other way to do this, and I'll just call this df1a, is there actually is a data frame command, and so I could do the same thing. And I think by default it assumes everything's coming in as like columns. I think there's a way to switch it. I know this, and so part of learning R, it really is learning a language. You kind of have to just start learning some of these basic commands and sort of put them in your tool chest. It's kind of like the first time if you've learned SAS, you have to learn all the different little proc commands. So, and there's lots of good books and cheat sheets and things like that out there, which while I'm standing here, let me look at something here real quick. Yeah, the stuff that I've built, and also make sure all of this is saved. I was trying to see. Yeah, there actually are a number of cheat sheets built into the RStudio help, but like some of this stuff wouldn't be there. There's some more advanced data manipulation stuff, but yeah, I was thinking there was like a basic intro one, but there isn't. So yes, question, comment.
So the first way it made every variable a character.
Yes. Yeah, so let me run this one, and I'll go ahead and just point this out while we're here. All right. So, and I haven't had a chance. I was going to kind of put this off until a little bit later, but R has different kinds of data objects, and so we've seen a few. Like X here is really a scalar. You know, it's a vector of length 1. It has one value in it. So Y and Y2 are both vectors. Y is actually a vector of integers. Y2 is a vector of numeric variables. So that cbind command, it took those things together, but it tries to make them so that everything's the same type. And since month abbreviation and month name are all characters, it just automatically makes Y and Y2 characters as well, because it's trying to make them all of the same type. But the data frame command actually creates something called a list. And the list in R is a workhorse. I would say, with rare exception, probably 90% of the stuff you'll be actually working with is lists or data frames. And the data frame is actually a subset of a list. So a data frame has to have, it has to be perfectly rectangular. In other words, every row has to be the same length, and every column has to have the same number of elements in it. So it makes up a rectangle. But data frames and lists, the components or the things inside this can be different types. So just like in SAS or SPSS, your variables, like one variable could be numeric, another variable could be a character variable. You can also have logic variables. So all these things can be mixed together. So the cbind command just assumes they're all the same, but the data frame command actually now has, you'll notice this says it has 12 observations of 4 variables. And if I click this little arrow, it'll actually show you these 4 variables consist of these 4 things. This first one's an integer, the second one is numeric, and we'll talk more about factors. It automatically defaulted, called these things factors, but these are basically character variables. And that's really handy because you would really like something so that you can carry all this stuff around, you know, and they can be mixed and matched a little bit. The reason that a list is more global than a data frame, the stuff in here does not have to be the same length. So, and again, this one wasn't in the notes, but I could show you this real quick. So I could say, you can actually, there actually is a list command, and in that I could mix things together. So I could put in X in here, I could put Y in here, and I could actually put in my, my data frame. So if I did that, this is now a list of 3 things. The first element is a number, the second element is an integer vector of length 12, and the third element in this list is a data frame. And I'm jumping ahead a little bit. The reason I wanted to show you this is that, like, suppose you go and do a linear regression. It actually creates a linear regression object. And that object includes the coefficients, the p-values, the confidence intervals. I'm trying to remember all the other stuff. I can't remember if it includes the ANOVA table. I mean, there's just, and it's this massive object. And so one of the things we'll be doing as we get into Workshop 4 is figuring out how to manipulate these objects and pull out the pieces that you want. So anyway, and I'm going to show you a really miniature example of that at the end of today. Yes?
So if you had done the data frame command and the things were the same length,
No. So it'll actually, I can't remember if, have you ever done this in Excel? Like, say you copy 5 cells and then you get ready to paste it, but you selected, let's say, 20 cells. It'll copy those 5 cells over 4 times. So R will do that. It's going to do its best to fill in the gaps. So if you were to mix and match things here, it would, whichever one was the shortest, it would just kind of start it over and repeat it until it filled up the space. Now, it won't do that in a list because a list is just generic. It'll take anything. But the data frame, it's going to try to make it a square or rectangular object. Yeah, you kind of have to know ahead of time. Yes. And this is not how you're really going to be working with data. I just want to point this out because you will run into these kinds of objects as you start using different procedures and packages and looking at output from different analyses. But this is kind of under the hood. I want you to see how these things get built up. And then I've got a data set that will import and export and, you know, just like the normal stuff we work with.